Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
We choose to go to where the puck is going rather than where it is. And the reason we do that is because we don't have to please Wall Street. It's really as simple as that. Kittyhawk is backed by Larry Page. Larry Page is famously ambitious. We have the financing to do something truly ambitious, to take a huge amount of risk on the hopes that it will not only make the future come sooner, but also catalyze change in the industry as a whole. I'm betting that we will, in fact, prove that autonomy, small, cheap, high volume, aircraft not only can be done, but will demonstrate a consumer demand out there that wakes up the industry.
Hey, everybody. Welcome back to The Vertical Space. Today, Luke and I interview Chris Anderson, the Chief Operating Officer and Chief Product Officer of Kittyhawk. Listen to his bio at the start of the podcast. Chris's background and experience is amazing. It's a great podcast. So foundational to this podcast is the importance Kittyhawk is placing on autonomy and on affordable aircraft. Listen to why Chris and Kittyhawk are so confident about autonomy. Also listen to our discussion on performance-based certification, about operating at automotive scale, which is critical for the affordable vehicle. Chris has a fresh perspective on infrastructure and infrastructure requirements, and where these aircraft may land with a low-touch model. And for you entrepreneurs, what it will take to use the sky more effectively and the fresh new opportunities in advanced air mobility. We also had to sneak in a few questions from his distinguished past as the author of The Long Tail and from his days at the helm of Wired magazine. Hey, listen, this is a long podcast, but it's well worth the fun ride. Enjoy.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Chris Anderson is the Chief Operating Officer and Chief Product Officer of Kittyhawk. Chris serves on the FAA's Advanced Aviation Advisory Committee and led the ASTM drone type certification standard setting process. He was previously CEO of 3DR, at the time America's largest drone company, and founder of the Linux Foundation's Drone Code Project. Before that, he was a longtime editor of Wired magazine and author of the New York Times bestselling books The Long Tail and Free, as well as an editor at The Economist magazine in London, Hong Kong, and New York. His background is in science, starting with studying computational physics and doing research at Los Alamos, which culminated in 6 years at the two leading scientific journals, Nature and Science. Chris, welcome to the show, and please meet Luka Tomjanovic.
Thanks, Jim, and nice to meet you, Luka.
Yeah, likewise. Welcome, Chris.
Chris, I'll have to say, in some ways, you're one of the most difficult people to prepare for with your vast work, companies you've started, industries you've shaped, books you've written, interviews you've conducted. However, at the same time, you're one of the easiest as we don't lack for questions. So this is so really looking forward to this.
Well, thank you. All those random things all kind of make sense in my head and probably in nobody else's. But but basically, we have a lot of physicists here at Kittyhawk and computational physicists. And when you think about it, it's, flying robots are kind of computational physics, and it kind of makes sense.
So I'm going to ask you kind of a weird question before we get to our standard first question. And you can choose to answer it now, Chris, or later, or not answer it at all. What's the one question, if you or we, that you would want to ask Chris Anderson?
That's interesting.
Or the question that our guests you think that we would most want to ask you?
So I was prepared for your standard opening question, which is, what is the one thing that everybody disagrees with you about? And
Right.
you pulled a fast one. Well, I mean, the question I get from everybody is, because we're taking such an unusual path here with autonomy, is, what makes you think that the path that you're on, which is with Kittyhawk of fully autonomous vehicles at the price of a car, what makes you think that could possibly work? Could it work? How could it work regulatorily? How could it work economically? How could it work socially, culturally, etc.? It's so different from what others are doing that we are either, you can either argue that we're divinely inspired or insane, but obviously I prefer the first to the second. But it is we certainly deal with our share of skepticism about the practicality of the course we're on, and people might rightly ask, why are we so confident given how risky it appears? You probably want me to answer that question, right?
Yes, please. I mean, you've asked the perfect question.
Well, first of all, I think we can all agree that autonomy is where the industry wants to be long term. The unit economics of not having a pilot, and my apologies. I know that one or both of you are pilots, but the unit economics.
Careful, Chris. Careful.
The economics don't work for having a pilot. We don't have enough pilots. One seat gets used. It's expensive. All that sort of stuff. So I think everyone agrees that autonomy is the future. And everyone probably also agrees, using the notion of flying car, that, one of the reasons the sky is empty is because it's quite expensive to get up there. And if airplanes were as cheap as cars and made in the same volume as cars, that would really change the nature of transportation and perhaps our world. So everyone agrees with that. Where they disagree on whether that is the way to start, or whether you should do it incrementally and move, with a pilot, then, bring in your electric, bring your transition, then take the pilot out, sort of a very gradual iterative process to get there. And we choose not to do that. We choose to go to where the puck is going rather than where it is. And the reason we do that is because we don't have to please Wall Street. It's really as simple as that. Kittyhawk is backed by Larry Page. Larry Page is famously ambitious. Lives somewhat in the future. His canonical method is 10. Whatever you give him, he would like 10 times that, or 1/10 that, or these orders of magnitude are his favorite tool. And we have the financing to do something truly ambitious, to take a huge amount of risk on the hopes that it will not only make the future come sooner, but also catalyze change in the industry as a whole. So we could be wrong, but we're funded to take that chance. And I'm betting that we will, in fact, prove that autonomy, small, cheap, high volume, aircraft not only can be done, but will demonstrate a consumer demand out there that wakes up the industry, including the regulators, and causes that compliance future to come sooner.
And I look forward to double clicking in each of those big pieces that you mentioned, the autonomy and manufacturing at scale. But we gotta stay true to our form and ask you, what is something that most of the industry disagrees with you on?
Well, I kind of just said it's just all that stuff. The industry believes, rightly so, that autonomy, certifying autonomy, which is going to take a long time, because certifying anything takes a long time. But because there's no path. No published path to certifying autonomy, the assumption is going to be decades. And I'm betting that's not going to be the case. Mm-hmm. And partly because there's ways to operate pre-certification outside the United States, military, things like that. And so I think we'll get in the air sooner. And the second is that Mike Huerta, the former administrator of the FAA, works with us, and he was one of the pioneers of performance-based certification. And performance-based, on the face of it, the notion is that industry comes up with a standard which achieves a equivalent level of safety, but through different means, brings it back to the FAA, and the FAA says, yeah, that can work, or modify it somewhat. Now, what that means is that we need to pioneer that standard, establish that safety case, build the case for equivalent level of safety, and bring it back to the FAA. Now, at that point, we hope the FAA will like it. We hope they will accept it. But until we show them something, there's nothing to talk about. So I think that we basically have confidence that the process will work. That performance-based is the opportunity to be creative in how we bring autonomy in, and the ball's in our court. We need to establish that safety case, bring the data, demonstrate the hours, and then come back to the FAA. And if we don't do it, who will?
Yeah, certainly autonomy is somewhat of a contentious issue. How do you look at, more broadly, piloted versus non-piloted passenger carrying eVTOLs? Understanding that removing the pilot from the cockpit certainly removes a significant cost, especially for small gauge aircraft, or perhaps not entirely removes it, but rather spreads it to multiple aircraft in a, call it, remote supervision kind of concept of operations.
Mm-hmm.
At the same time, there are additional costs that are associated with more sophisticated avionics, a stronger autonomy stack on board that's certainly more expensive, certification, plus, the go-to-market is likely delayed as you compare it to some of the piloted vehicles. How do you look at this trade-off? Yeah. Is it short-term pain for long-term gain, as you mentioned? Is it following where the puck is going ultimately?
I may disqualify myself by exhibiting naivete. I don't see the short-term pain. Remember, I came from the drone industry, which is where autonomy was just the way it was. We built the Pixhawk autopilots and the PX4 stack. We got a decade of great experience in autonomy. It seems that doesn't seem hard to me, nor does it seem expensive. Now, recognizing that drone levels of safety and performance are not the same as crewed aircraft, but that is But we suffer from confidence, perhaps overconfidence, from having done it so successfully with drones, and cheaply as well. A drone autopilot costs $200, and they're pretty good when you look at just the millions of hours that are being flown today with drone delivery, etc. The track record is really excellent. Now, again, we don't have things like triplex redundancy, built in. We certainly don't have, the same sort of weather, lightning, HERF protection that you might have for, we might require for crewed aircraft. But those are not autonomy problems. Those are just kind of, aircraft problems, and there's conventional ways to solve that. The economics that you described are so compelling. It's not just taking the pilot out from the aircraft and having it on the ground, but also, as you hinted at, changing the ratio from 1-to-1 to 1-to-many. Maybe one operator for 20 aircraft, or starts to look more like air traffic control than piloting. And not only that, but to be faithful to our low cost model, we need to do the same with the ground operations. So forget, we cannot be locked to vertiports with lots of staff and concierge and things like that. These things have to be able to land anywhere, have an unattended operation, basically be a low touch operations model in addition to being a cheap aircraft model. The goal is to get under $1 a mile. We think 50 cents a mile is attainable, which is, maybe a tenth what the piloted aircraft eVTOL companies are guessing at.
So tell us more about the certification process. You mentioned that you're not waiting for certification. I imagine you mean international and defense applications, but if you bring that over to the passenger carrying commercial use cases, what's involved in certifying an autonomous eVTOL?
Yeah, I mean that is the $50,000 question, or a million or billion, or depending on how you're keeping score. It is not yet. The FAA hasn't given a path, given the criteria, the means of compliance for certification. And B, performance-based certification is still quite new. We do have some precedent with drones. And as you mentioned before, I led the ASTM working group that came up with the drone certification standard. It's called durability and reliability. That was also based on the performance-based regime. And that one, I was really encouraged by that. The ASTM process went very well. And basically, for the listeners who may not be familiar with the drone certification, it's based on a number of hours, so 400 hours of flight time, and then a list of tests, basically, mission profiles and failure injections. And so, those things, the hours prove the durability and reliability, and then the mission profiles and the failure injections that you run through represent our are what's called representative operations. So they describe the environment, the operational envelope that you intend to operate in, and that went really well. The FAA liked that. They adopted that. 10 aircraft manufacturers went through that process, of which 3DR was one, but others are Google Wing, Amazon Prime, Matternet, and Zipline and others.
Still to date, have there been certifications?
There have been none. There have been no certifications, and you might ask, why? This was supposed to be a 6-month streamlined process. The answer, it's been an eye-opening experience, and the answer is that the devil is in the details, as you might imagine. And I'm going to do a little violence to the subtlety of this, but basically it came down to the definition of an aircraft. So you think of an airplane being an airplane. Of course, a SUAS, UAS is a system. It's the aircraft, it's the communications link, and it's the ground control system. So that's that whole system. Now that needs to be certified. Okay, well, fair enough. Now, when you look at the communications and the ground control station, imagine, if you will, that the communication system is called cell phone towers and the internet, and the ground control station is called an iPhone, which, by the way, reflects a zip line or a wing operation very well. And now the FAA says, wait, we have to certify the internet? How do you configuration lock the internet? Where is this internet? What's the backup power system for the internet? You can see that starts to raise kind of almost taxonomical issues. And then, typically take the ground control station. Let's say it's an app running on an iPhone. How do you lock configuration on an iPhone, since Apple controls the operating system and can update accordingly? So this, the FAA found it really difficult to meet their level of let's say configuration lock for this internet-based system. And so they said, okay, we'll tell you, we'll just take that out. We'll call that additional equipage. We'll take it out of the certification. We'll kick that down the road to flight standards and let them deal with it. Well, two problems. One, flight standards doesn't have a particularly good idea on how to certify those elements either. And it meant reissuing the G1s and the means of compliance and all that other kind of stuff. And then there's a turf war within the FAA about how they're going to do this. But it was really just as simple as this, is the internet broke the FAA.
So we're getting into a bit of a tangent, but I like this. Does that mean that we're moving towards aviation protected spectrum?
No, I mean, obviously the right answer is yes, use the internet. Yes, use LTE or 5G. Why not? But understand what the operational, consequences are of that. And let's just take using your internet as your main C2 link. Okay, well, it's going to work most of the time. It's going to work most of the places, but not every time, and not all places. Okay, so when it isn't working, when you've lost that link, then what? Well, do you have a backup link? Do you have maybe satellite communications as your backup link? Okay, that could be one mitigation. Or does your autonomy work so well that you can operate without a link for a short period of time? Hopefully doesn't happen very often, and reliably, and demonstrate that. So those are mitigations that can be considered. There's been a lot of talk, by the way, about hardening the LTE or the cell phone infrastructure to be more appropriate for aerospace use, and there's ways to do that. So the towers can actually do a quality of service thing, et cetera. So I think that's, I think that there's some good creative thinking.
It's a systems engineering challenge.
It's a system engineering challenge, but the answer is not to go back to peer-to-peer, point-to-point radios or satellite communications. I mean, I think broadly we should use modern technology infrastructure, be it the sensor chips that we use in the autopilots, or the internet itself, or the cloud. But we should find a way to ascertain just what the safety consequences are of that.
Can we now, circle back to autonomy certification path for eVTOL? We had a nice detour about small UAS, but without a path, without some means of compliance, and with performance-based certification still in its early life, how does that uncertainty shape your product development strategy, and how do you then work towards something that is so vague?
Yeah, we think of nothing else is the answer. So in the absence of a published path to certifying autonomy. We have to use our judgment and precedent and experience elsewhere. So obviously the drone experience was some precedent, but clearly that's in the low risk category, under 55 pounds, and we're going into a different risk category. Part 23 is something that we peruse as closely as we can, but doesn't really speak to this. The standards bodies have been thinking a lot about certifying complex systems and autonomy, and so we participate with ASTM. RTCA has some thoughts on this. NASA has some thoughts on this, and so there's a lot of good industry thinking. There's also precedent in self-driving cars. So certifying the autonomy stacks for cars also gives us some precedent and some code that we can use that at least has been shown safe in a different context, and that may be, and we may get credit for that explicitly or implicitly, with the FAA. And then we talk with our colleagues in the Autonomy Coalition about, best practice. And then, at the end of the day, we cannot wait for the FAA to tell us how to do it. We have to make our own decisions. And that's going to be based on just Silicon Valley, engineering excellence, as well as building a safety case that makes kind of rational sense to us and internally, and then putting tons and tons of hours on these things in an uncrewed context, so that when we bring something to the FAA, it's not just a theory, but it comes with real world data to show the theory works.
Chris, we had a guest on who said that he believed autonomous air vehicles would follow ground vehicles by 5 to 10 years. What's your perspective?
I remember that, his comment, and I think he was referring to sort of like adoption of rather than certification of, since ground vehicles are not exactly certified in the same way. I think that's what he meant. Well, I think that's probably right. I mean, obviously we have autonomous vehicles, air vehicles today in an unmanned context. Those were all the drones that we made. The problem is we get into the definitions of autonomy. So like my Tesla, I don't even have full self-driving, but just in autopilot mode, it's not truly autonomous. It's a driver assist function. Put on full self-driving, it's still not really autonomous. I think by autonomy we're talking about literally no steering wheel kind of thing. That's a little bit like what Cruise is doing in San Francisco right now, and Waymo's doing in Phoenix, where you really do have no driver in the in the vehicle. So you could argue that already exists today. You can sign up to have your commute in San Francisco be autonomous today. So add 5 years to it, and that sounds about right.
Can you tell us more about the tech stack that you're building into your aircraft for things like detect and void and command and control, the overall system approach?
I'm going to try. Obviously I shouldn't be giving everything away.
We'll have exclusives, by the way.
Yeah. On the tech stack, obviously it is autonomous. Because it's autonomous, we need redundancy. We're probably, our exact redundancy strategy is it triplex? Is it dissimilar? Is it similar? It's all that. That's a little bit of our secret sauce, and I probably shouldn't talk about that. But let's just say that we've thought about it, and we have, I think, a pretty good plan. Detect and avoid, unsolved problem. Right now, we're evaluating all the detect and avoid solutions: optical, acoustic, radar, ground-based, ADS-B. All of the above. I don't think we have I don't think we've settled on what we absolutely have not settled on a solution. And also, we're not even sure whether this going to be an operational thing where you only operate where there is a sort of a ground-based infrastructure, let's say, that does detect and avoid for you, or whether it has to be something the aircraft itself needs to be able to do everywhere, all the time. So I think that one is kind of the biggest head scratcher, for me right now is what the right DAA strategy is going to be long term. On C2, we actually it's LTE with SATCOM's backup, and then peer-to-peer, and then point-to-point rather, during our test period. So that's actually working pretty well, although again, our C2 link is, when you think about remote piloting, some people may think that there's like there's a pilot with a hat on and she's got a yoke or something and is actually steering the plane. It's not that. It's closer to an autopilot. At most it's a kind of heading, altitude, sort of control. In many cases, as we've seen with drones, it's actually more of a point and click experience, but it doesn't require a high bandwidth, low latency comms link.
So with LTE as a primary C2 link, that works up to a certain altitude.
Well, yes, that altitude happens to correspond very neatly with our planned operational altitude. So think of like 1,000 to 3,000 feet. That's a very credible eVTOL altitude. Also think about urban environments at that altitude. It actually the Venn overlap between that and the LTE coverage is pretty good.
Mm-hmm. And so besides the DAA, what are some of the other remaining gaps in technology
Precision
to
land.
get
So
to
again,
get to certified and trusted autonomy?
yeah,
Precisely.
yeah. So we want to make this so they can land outside of vertiports. So land anywhere, not exactly anywhere, but sort of in designated, safe places to land, called parking lots or parks or things like that. Obviously, we need a good precision landing, because again, this is autonomous primarily and only remotely supervised. So precision landing means not just being able to land, on an identified spot, but also to be able to ensure that spot is in fact clear to land. And the analogy you might see with our sort of our corporate cousin Waymo, is that they do autonomous pickup and drop off, and they pre-survey a city for locations that are likely to be a safe place to pick up and drop off. But any one of those could have a car parked in it, and so you have a map of places that you are candidates for landing, but then you need to be able to autonomously, using computer vision, et cetera, confirm the place is still, in fact, safe to land before you land there. So that's a technical challenge, a computer vision, challenge and beyond. And then doing it in a way that's demonstrably safe is going to be a challenge as well. So obviously, we'll start with the easy stuff, like actually starting with like airports and vertiports, and then we'll go to the next easy stuff, which is like walled off areas and parking lots, et cetera, that have like some sort of optical fiducial that's really easy to see. But then we'll keep moving on as we get more confidence, and we'll have the ability to dynamically assess the site in real time.
Before we move off of autonomy, I just want to ask, there's going to be an awful lot of listeners who are going to say, wow, what is Chris talking about? He's really leaning in here.
Yeah.
What objections do you get, Chris, that you think are the most legitimate objections to what you're saying? And what do you think are the greatest misunderstandings as it relates to autonomy?
Yeah. Well, I think there's three obvious objections. One is that we can't make it safe, and I humbly disagree with some experience. The other is that people won't trust it. That passengers will just sort of like not want to get into a vehicle without a pilot, and that's a fair concern. We'll find out. EHang in China has started doing that. Passengers there seem to like it, but it's a social question. It's a psychological question. But we're assuming the passengers will like the experience. We have there is an operator. There's a screen in the cabin. When you get in, a human being greets you on the screen by name, just as you would in a Lyft and Uber, and they're always available. A button press away. There's always that human who's there to reassure you or tell you how things are going. But it may be people just don't like it. I think it's unlikely, but we have to accept that possibility. And the third is that the compliance, the regulatory barriers are just way higher and longer than we believe. We think that we can fly somewhere in the world in the next year or two. Well, we're already flying. We've flown thousands of flights on our own property, but we think we can fly more places in the world to get commercial learnings. There'll obviously be sanitized airspace or in military operations. We work with Agility Prime or other parts of the country, but we do think there will be some location somewhere in the world that wants to be the first to bring in passenger operations autonomously, and we endeavor to find that entity, that place, and be that first, and then we'll find out whether in fact that leads to a quicker adoption in the United States and Europe, or doesn't.
When do you expect initial commercial operations, either in the U.S. or abroad?
I'm not sure I'm allowed to answer that one because commercial operations means, so obviously we have operations already, but we're not charging for a service. Commercial operations means charging for a service. Obviously we want, our objective here is to fly humans, not cargo. Would we be prepared to fly cargo or just demonstrations of various sorts without humans initially to get some learnings? For sure, but that's not our business, and we probably wouldn't charge for that, so that probably doesn't count.
So maybe let me rephrase: is it within 5 years or 10 years?
Certainly within 5 years. Remember, we are gated right now primarily by our internal safety bar. So we're building in our own case, and when we feel, and we have obviously I think a very thoughtful internal safety case, but when we feel we've hit our internal safety case and it is safe to fly a human, then we will do so. And whether we charge for that or not, I don't know, but that's going to be, we may be flying a human this year.
Oh, wow. Nice. And so can you tell us a bit more about what this product will look like? How many seats? Is it going to be based on will it be the heavy side?
No, it will not look anything like so heavy side, for those who don't know, is the vehicle that we've been flying for 3 or 4 years. It's beautiful machine tilt rotor, single seat, but not an air taxi. Doesn't have a door, among other things. It was really designed as a kind of technology demonstrator, and we learned a ton from that. The vehicle that actually would be a potential air taxi will obviously be configured accordingly. You'll have a door. Might have it'll have an internal cabin that satisfies those kind of human factors that we talked about, like a screen and the ability to talk to the remote operator and all that sort of thing. Size wise, it is single seat. It will be the lightest vehicle on the market by like a factor of 3 or more. It'll be the cheapest vehicle on the market by a factor of 3 or more. These two go together. It basically shows what happens when you go with autonomy. A single seat becomes an option, and when you go for a single seat, you really you want to capitalize on small and light and inexpensive, because not only does it it makes it easier to land in more places. You're not limited to large vertiports. It means that the cost of the flight can be lower, which means it has there are more markets that you can go to. There's more economic models that fit. It may even be easier to certify because there's just less to it.
Mm-hmm. Are you allowed to share much about the configuration? Tilt wing, tilt rotors?
It's like our Heaviside H2 and tilt rotor. That's kind of we love that. It works really well for us. So it's tilt rotor. It's got a wing. Yeah, that's about all I can say.
You have talked about aerospace technology at an automotive scale. Tell us a little bit about that, Chris.
Yeah. So this is, again, it's quite obvious that if you want to move the needle for the world for transportation, the world at large, you have to basically operate at automotive scale. Our objective is to take 10% of the road miles in the cities where we operate take 10% of those miles off the road into the air. So you do the math on that, and that's thousands of vehicles, thousands of airplanes, flying. That's what you need to do to basically, because when you're doing road miles, you're basically taking highway miles and turning them into skyway miles. But you need thousands of vehicles flying simultaneously in that market. The only way you move the needle is to start operating at automotive scale. The largest U.S. producer of airplanes, I believe, is Textron. That's maybe Cirrus. That's around 600 vehicles a year. An automotive manufacturer will make 6 million vehicles a year. Now, I'm not suggesting we're going to get straight there, but obviously to move the needle, we need to be operating at much higher volume than any other aircraft manufacturer is. And the notions of we'll start with hundreds per year, and then we'll get to thousands per year, and then ultimately it has to get to 10,000 per year. So the more the volume goes up, the more you start to take learnings and processes from adjacent industries, and the cars are the closest to it. A lot of people, and some of your guests, have talked about how people naively come into this and say, why don't we make airplanes like cars? And it turns out there are reasons, involving weight and that sort of thing. But we, given that our vehicle is sort of car sized, given that it has a relatively low parts count, thanks to autonomy and electricity and things like that, we are definitely taking some tips from the automotive industry, mostly about automation, some tips about materials and manufacturing methods. There's been obviously a huge amount of innovation in not just composite materials. 3D printing is changing dramatically right now. And, if you go to a Tesla plant, right now where they're stamping aluminum, there's definitely some bits there that look useful for what we're doing. I can't say a bunch more about it other than we think that $50,000 per vehicle is attainable. But per airplane rather is attainable. And if it is attainable, then it's going to be because we used volume as to our advantage. And so think about vehicles made in the thousands costing $50,000, and that's what we need to actually have the impact we want in the skies. And maybe we're wrong and naive about this. We almost certainly are some wrong and naive about some elements, but again, if you think of the ambitions of our funder, that's the kind of chance, that's the kind of experiment you need to run to have the impact that he wants.
How far are you currently from that goal of 1,000 vehicles per year at $50,000 bill of materials?
Pretty far on the volume.
Mm-hmm.
So we've made something on the order. Well, Kittyhawk's been around for 12 years, and there's been in many vehicles. There was the Flyer vehicle, which some of you may remember was an ultralight that kind of flew over water. I think hundreds of them were made, or at least more than 100 of them were made, and thousands of flights were made. Our current heavyside vehicle, H2, right now, I think we're on serial number. I think we're on about 18 of that, and we'll probably get to about the serial number 30 this year, and that'll be the end of that line. So we have some credibility. We've made a lot of things, and more than most. But to get to the level I'm talking about, we're going to have to go from a vehicle a month to a vehicle every 2 days.
Yeah, we had Scott Drennan as a guest earlier in our podcast, and I really liked his comments on getting aerospace to move at even just one order of magnitude greater scale than traditional aviation. And he points out that there's a cost of quality in both capital, in time, in first pass yields. And because of a much more restrictive requirement in aviation and quality-driven processes and all of that, we don't really have the luxury of cutting corners to achieve speed, like choosing, less expensive tools or using materials that are not as capable. So how do you combine these two realities, manufacture faster, but still keep the appropriate levels of quality?
Well, there's the appropriate levels of quality, and then there's the certifiable levels of quality, which may not be exactly the same thing in a performance-based regime. Could we have a conventionally certified aircraft today at automotive scale? No, for just the reasons you said. But as we move into this new realm where we're exploring different ways to think about aerospace, including autonomy and materials and manufacturing methods in a performance-based regime, the thesis is, and we'll see whether it works, the thesis is that if we can come up with a better process that's equally safe, that the FAA would consider it.
So for all those aspiring founders thinking about ways to innovate and create value, what are some of the areas for them to focus on?
Well, there's a lot of unobtainium out there in what we're doing. There's a lot of things that haven't been invented. I feel like we've got the autonomy stack pretty dialed in right now, and so I think again, lots of experience in my previous career on that. What we're then working on is the sort of demonstrated the certifiability of the autonomy stack, and in that one, we do have the benefit of working with adjacent spaces. So the Linux Foundation has an entire program on certifiable open source for things like process communications and the RTOS and things like that. There's many autonomous car companies in our neighborhood, quite literally sometimes, and they're also thinking about this problem. So, both the FAA and the FAA is part of the Department of Transportation as the monitoring of cars. So we believe that there's some cross fertilization opportunities between those. But thinking about how do you demonstrate safety? How do you the old way deal in software DO 178C the V-shaped model and all that's certainly one way. It's not the way Silicon Valley writes software. We're really good at writing software, but we don't write it with a requirements-based, V-shaped process. It tends to be more iterative, and we have a lot of sort of, unit tests and continuous integration and simulation and all this kind of stuff. And I think one of the interesting questions is how do we take the best of Silicon Valley software development and make it demonstrably and incredibly safe, such that a regulator can understand it. I think there's some really interesting work to be done in simulation there, and I used to lead a working group specifically on using simulation for credit, as part of a certification regime, which is still brand new. But yeah, so those are basically how do you make something that is sort of nimble and safe, cheap and safe, sort of Silicon Valley processes that are credible to conventional industries. That's where all the opportunity is that I can see right now.
Can you tell us about the level of digital engineering or digital threads and twins that you're using in the design of your aircraft?
Well, obviously we so we obviously we do, CAD and all that kind of stuff. I think there's a lot of interesting work done. I mentioned simulation before. When you think about all the simulation we do, we use on the aerostructures side, we use, FEA analysis. We have all sorts of structures analysis. We CFD as well. Then we have on our software side, we have both software in the loop and hardware in the loop simulation. Then we have physics models that allow us to kind of get really deep into both the internals of the vehicle and the externals, the climate and the environment. And then you have traffic simulation, which now imagines the network. You're simulating the network and cooperative and non-cooperative traffic. Then you've got the actual simulator that you sit in, so that we can start to get focus groups and customer feedback on an experience that works for them. When you think about it, we probably have about 7 different simulators, a different stack levels of the stack, all contributing to our design. And I'm a huge, as you can tell, I'm a huge fan of this. And one of the projects I was leading was really, to the extent that we want to be able to not go through a conventional certification process, but rather sort of say, look, take the software in particular, let's say you run the software through, as you do with autonomous cars, let's say you run it through 1 million hours of simulated operations, including a very wide range of envelopes, much wider than you would see. So you've got dynamically generated, scenarios of every possible edge case. That should be a good thing, right? That's definitely easier to do in simulation than it is in the real world. Is it going to be persuasive to regulators that you did, 1 billion hours with every possible permutation of edge cases? I think it should be useful to them, possibly even persuasive. How do you combine that and validate the simulation as being accurate? Well, we also have a project on that where there's these domains where we do real world and simulation, ascertain the fidelity of the simulator, and then extend that to domains where we can't do real world and assume the simulator is good there as well. Mm-hmm. So there's, it's a long answer, but as far as digital tools go, simulation is probably the most exciting one.
Yeah, it's encouraging to see that you're drawing the system box really wide.
Yeah, I mean, including network operations. Yeah.
Yeah, absolutely. So, Chris, as head of product at Kittyhawk, how do you go about defining and driving your product requirements, especially in a nascent industry with so many remaining uncertainties and unknowns?
So you use the R word, which is triggered me. So the funny thing is,
priorities.
Well, aerospace culture is all about requirements. And and Silicon Valley culture is typically not. It's more an emergent kind of organic development. So you center, you might have an architecture, but requirements is one of those things that's almost unique. At least the way you define it probably is almost unique to aerospace. And it's a little alien to me to be kind of entirely requirements driven, as opposed to iterative or bottoms up, development. We have a culture, we have 2 cultures within the company. We have sort of Silicon Valley culture, which includes drone culture, and then you have classic aerospace culture. And the aerospace folks want requirements. And I've been trying to, I never give them the requirements that they want. Never enough of them. Never specific enough. And I just say no, because I just don't know, because we're just guessing at what the ultimate market is going to be. I don't want to lock something in, and I've tried to think of why they're so hungry for requirements. And I realized that because aerospace is all about trades. It's all about trade-offs between things, and you basically have a system of linear equations, and with this X number of, ideally you have the same number of variables as you have equations, and you can solve the system of linear equations. If you have more variables than you have equations, then it's unsolvable. And what these requirements really are is turning variables into constants. They want some things to be locked down, the payload or the takeoff weight or the range. They want those things to be locked down so that they can figure out what the implications and consequences are for these other things. And I don't want to lock those things down because A, I'd be guessing, which is not good. B, we haven't even figured out what the ideal market is. So how could I figure out what the ideal performance is? And C, I kind of I want those things to emerge. I want to set a much higher level ambition. So let's say our ambition is 50 cents a mile, period. Let's say that's it. That's the only requirement. 50 cents a mile. Let everything else flow from that. Now, you as an aerospace engineer would probably say, I need more, right? and yet if you put yourself in in my boss's head, That's what he wants. He wants these things to be out there, to move the needle, to be out there in huge volumes, making a significant dent in our traffic patterns. How do you do that? Well, you lower the economic barrier to one where it's actually economically it's cheaper to fly than it is to drive.
So if you've lowered the cost to where you want it to be, and in some ways you're saying the use case will come.
Yeah.
If Kittyhawk is wildly successful in 5 or 10 years, what are the more likely use cases you think will create that demand?
Well, in economics, there's a term called Say's law, which is supply creates its own demand.
Mm-hmm.
So let's imagine, for the sake of argument, that I can't remember where you guys live. Where do you live? For
Connecticut and
Bay Area.
California.
Okay, so Connecticut and Bay Area, both of them have commute issues. I used to live in Connecticut. So you commuted into New York. Now I live in sort of East Bay, but Berkeley, and I commute down to Palo Alto. In both cases, I had about an hour-long commute. I know technically I can turn that commute into 10 minutes, maybe 15. Flying as the crow flies, a little faster than a car, twice as fast as a car, et cetera. And because our vehicles are small, presumably they can land a lot closer to where I live and where I work than if I have to drive to a vertiport and do a multimodal thing. So let's say, I wake up in the morning and I'm like, okay, time to go to Palo Alto. I pull out my app. I order a Kittyhawk air taxi. In the 5 minutes it takes to arrive, I walk to the local park where I know where I've asked for it to pick me up, and I get in, and then it flies me right over the bay to my work and lands in a parking lot, again, walking distance from my office. That sounds great. I would totally do that. It would be faster. It would be no more expensive, possibly cheaper. It'd be a great flight. What's not to like? So I think in that scenario, it's a commute replacement, and it's really easy to imagine people. If it really is as simple as that, it'd be very easy to imagine people just choosing that form of transportation because it's faster and cheaper. Now, what else might it be? Where else might that be useful? Well, I know that, the military thinks about autonomy as a way to get soldiers out of harm's way. So if you have an injured soldier, you don't want to put another human in harm's way. So the idea of sending an autonomous vehicle to pick up an injured soldier and bring them back is a good thing. That's one. There's, EHong has clearly demonstrated, tourism and sightseeing as a utility. I'm not sure how big that is, but there's another one. But basically wherever there's highways, there could be skyways, and that's kind of our thesis.
How do you reconcile those two mentalities, the Silicon Valley versus the traditional aerospace?
Story of my life.
Great question.
Yeah, I'm not there yet. I've certainly come a long way towards aerospace. I started with complete ignorance about aerospace culture, and then 5 years of going through FAA certification with 3DR, and now running a team mostly made up of aerospace people. I've learned a lot. I've learned to respect. I think that the one difference is just the pace at which aerospace is done. Aerospace is it takes 5-10 years to design an airplane. That's completely normal. Where I'm more used to sort of a consumer electronics pace, which is 9 months to design a product. And so and the amount of planning that goes into something like that is a little is somewhat new. And then, of course, safety and compliance are massive issues that is not the primary driver in most other industries. Obviously, in consumer electronics, which is where I was previously, obviously a great consumer experience has to be there. The thing can't brick. It has to you can't do a recall. The failure rate has to be low. So all that kind of quality control stuff, that's common to the two industries. It's just achieved through different means.
Do you think that technology will bridge that gap? Or is it more than technology?
Well, again, I'm hoping that we can come up with alternative means of demonstrating safety that don't require quite so much process, that don't require the full, DO 178C, verification, requirements and then code. We're hoping there's a way that you can establish the integrity of software through, let's say, lighter weight means that use technology like continuous integration and simulation to achieve similar aim.
how do you think about vertical integration at Kittyhawk? Most companies in the industry today adopt a pretty heavy vertical integration approach, either due to the absence of an adequately developed supply chain or in order to tightly control all aspects of development and later operations. What's it like at Kittyhawk, and how do you see this trend of vertical integration persisting in the future?
Yeah, we do exactly the same. We're highly vertically integrated. And as a matter of fact, one of the ways we establish our cost controls is by being vertically integrated. So we can't just buy off the shelf avionics for a couple of reasons. Number one, they don't do what we want because autonomy. And the other is that they're just too expensive. So yeah, I think it's going to be, Tesla's highly vertically integrated, even at this scale. And I think that that's probably going to be our model as well. When I think about the things that we may, so we don't make our own batteries. So that's, that's one bit. We may end up partnering with, as we scale up to very large scale, we may end up partnering with other manufacturers, contract manufacturers or custom manufacturers, because, building a factory that can operate at that scale is it's $1 billion exercise. And there's a bunch of companies out there, and some of the more progressive, the manufacturing companies that want to get into this industry and are willing to kind of work with us to ultimately build factories at that scale. So that's, I think, a place where we may end up horizontally integrating.
So at what point do you think that the advanced air mobility value chain will develop into a very sort of rich horizontal?
Yeah, it's a great question. We would, now I'm not speaking for Kittyhawk or my bosses, but, my history has always been open source, creating, platforms for other people to innovate. So Pixhawk and Drone Code and things like that are example. So I would very much like to, once we develop these technologies, avionics, et cetera, autonomy stacks, I would very much like to make them available to others to use, mostly because I want to catalyze change in the industry. And the more I can make it easier for other people to follow our path, the more they will.
What's the smartest yet most difficult question that's asked about Kittyhawk that you most fear and is most difficult to answer?
It's probably the psychological one about autonomy. Do passengers are passengers willing to get into an aircraft without a pilot in the seat? Mm-hmm. I have a thesis on it, but my thesis is as good as yours. I'm guessing. We obviously are starting to see examples in cars. We're starting to see examples with like eHang in aircraft. But I think it's going to be a great experience. There is a human being. They're just not in the seat next to them. I think they'll be thrilled by it, and then after the third flight, they won't even think about it anymore. But I could very well be wrong, and I don't think that I have any grounds to tell people that we're right about this, because time will tell.
Mm-hmm. Foreign policy said that Chris Anderson has been called many things: a visionary, a pioneer of the internet economy, a proselytizer of do-it-yourself 2.0. But it's probably more apt to think of him as a weather vane. He may not control the winds of change, but he's often the first to see which way they're blowing. So where are the winds blowing in mobility and logistics and transportation, Chris?
Yeah, well, as you might guess, the topic we've been talking about is just autonomy. I think that the reason, look, I didn't know that autonomy was going to be my white whale, but around 2007, when I was at the time as the editor of Wired, and I was trying to get my kids excited about science and technology, and I said, robots, that'll be cool, and they did not think robots were cool. And I said, well, flying robots, that'd be cooler. And they're like, maybe. And then we ended up, the story is now somewhat legendary, but we ended up building a autopilot out of a Lego Mindstorms kit and putting it in an airplane, and it kind of worked. But they lost interest. I pursued that. And what happened is 2007 was a year at which the iPhone came out. There was 3D printing. There was the maker movement. There was Arduino. A bunch of things suddenly came together to make flying robots possible, such that I could do it on the dining room table with my kids, and ultimately communities could do it, and then we could do it better and better, et cetera. And so I think this is the golden age of autonomy. I think we're just starting to see what autonomy can change. Cars being one example, but airplanes being the next. And I'm if you're going to pick one thing, that I'm kind of betting my career on, it's that is that robots can do this job of transportation better than humans can, cheaper, more safely, at higher scale, and it's just time to do it.
If you could start a company today, what would that be?
I think it would be this one, except for I'd need a lot of money. Yeah, no, I can't think. I mean, literally, this is the continuation of the journey we started with 3DR and drones. The objective was, I joke that the empty sky is market failure, right? It is. A road is a one-dimensional problem. We have congestion. The water is a two-dimensional problem. You have less congestion. The air is a three-dimensional problem. You would have less congestion yet. There's only three reasons why why the air is empty, and why the largest American manufacturer makes 600 units a year. And the reason number one is economics. It's too expensive. Reason number two is regulation, and reason number three is technology. We don't have cheap, legal, autonomous vehicles, but if we did, we would be using the sky much, much more effectively. So that was the thesis, by the way, we had for drones as well. And we made 1 million of them. It worked really well, but we hit a roadblock where it came to going beyond visual line of sight. That was the regulatory roadblock. Even if we succeeded, I don't think that the drones move the needle for the global economy as much as air taxis will. So this is just it's the same mission, just now taken to a bigger market.
So just a quick question on 3DR. Started building drones. I think the company later pivoted to doing software. Mm-hmm. Was it primarily because of the regulatory barrier that you just mentioned, or chasing a more valuable part of the value chain? Yeah,
I mean, from the outside perspective, it looks like we got crushed by DJI, which is true, by the way. But the reason we got crushed by DJI is that our bet had always been on sort of commercial enterprise use of drones, using autonomy to basically, to use human power more effectively. So right now, a drone still needs a pilot. And that's a 1-to-1 ratio. And so we haven't really achieved any cost savings. The mission was always to amplify human potential by changing the ratio, having one operator with hundreds of drones, more like a drone light show than what we currently see with surveying and inspection. That requires two things. It requires A, the drones to fly beyond visual line of sight, and B, for that ratio of pilot to aircraft to go beyond 1-to-1. Both of those are not currently permitted. Both of those require type certification, and so we're stuck. So we bet early on that autonomy was the future, and everything I described was the future. And we assumed that the regulatory barriers had been falling very rapidly. First there was recreational use, then Part 107 allowed for commercial use. There were things like, the Lance program. There's a bunch of very encouraging early signs that suggested that, that the regulatory path was going to open up more quickly than it did. But then we got roadblocked on beyond visual line of sight. And that was it. We didn't really have, then the only market available was a consumer market, which is largely videography and photography, which is not our core competence. We weren't a camera company. DJI was a camera company. And so in the consumer market, price matters. So it was a race to the bottom, and they had fantastic vehicles with great cameras, and that just wasn't our thing. And the market for our autonomous, smart, we had the two Linux computers on board, one on board and one in the ground control station. We were completely over-engineered to do something much more ambitious. And the market just didn't open up quickly enough for us. Interestingly, Skydio, which is now, I know you had Brenton from Skydio more recently. Skydio is now doing what we had originally envisioned, which is autonomy and smart shots and all this kind of stuff. And they're doing it with, primarily for close range stuff, infrastructure inspection and consumer stuff like videography. And they're doing fine, but we were too early.
So first of all, for our guests, if you haven't read The Long Tail, you have to read the book. How would you apply The Long Tail to advanced air mobility?
Oh goodness! I should have seen that one coming. Well, so the long tail is the notion that for those who haven't read it, that choice, the choice of products you have available to you, is limited by distribution. So if you have limited shelf space, you're going to have limited choice. If you have unlimited shelf space, you have unlimited choice. Spotify versus the record store, and that once you offer people unlimited choice, it turns out they may want different things than what you had seen previously when you only had three different items they could choose from. And so what it reveals is the range of differentiation in the population, and which you can measure in terms of products that they choose. So what enabled the long tail was the internet, which gave us infinite shelf space. We do have an analogy here in aerospace, which is right now, if you want to fly from point A to point B, you got to go to an airport by and large.
Right.
So they think of that as shelf space, right? And airports have their own costs and the aircraft have their own costs. And so you have a very expensive distribution of aircraft between all those elements. Well, imagine that if you could, if the aircraft were much cheaper and could be anywhere outside of airports, then you would be discovering new choice, if you will, new demand patterns that were not revealed by the airport era. So that's
I think it's
my best effort.
It's funny, when I was reading the book, Luke, I thought about you and Peter talking about the vertical space. And can you imagine the day where you could have affordable, convenient transportation? We're more likely to access the vertical space. Then I thought that's the long tail.
Exactly.
That's how you've answered it.
Absolutely. Chris, if you fast forward 5 years or 10 years, what does the industry look like?
Well, it's easier for me to say what we look like. We will be flying autonomous vehicles at scale, carrying people. Where? I don't know. I can guess, but we'll see. But we'll be there. We will hit our internal targets of safety case, maturity, manufacturing, production, etc. So my hope is that in doing so, we will have opened a lot of eyes. We've opened the eyes of the regulators as to what's possible and safe. We've opened eyes of locations as to what those cities could look like in the future, and open the eyes to consumers of how they want that. And then I would hope that a lot of others would then follow us. And right now, I think people would consider us, an outlier is probably the nicest way to put it, because there's no evidence that we're right. But 5 years from now, there will be evidence, and then hopefully people will not think it's so crazy.
And what advice would you give to someone who wants to start a business in advanced air mobility?
Normally, it would be a kind of picks and shovels kind of argument, which is like, oh, there's this like layer that's missing. Right now, go do that. Our big unobtainiums right now are things like energy density of batteries and autonomy. These are really expensive things. I wouldn't start a battery business right now. That's a lot to chew off. I've also seen people kind of coming at little point solutions about DAA solutions and things like that. That's another tough road, because again, the path to knowing what is the right solution, what is ultimately going to be accepted by the industry and the regulators, we don't know yet, and so there's a lot of risk in that involved. I know a lot of people are interested in this sort of the infrastructure side of it, vertiports and things like that. My instinct would be if someone came to us and they said, "Hey, we have this location where we have permission for you to fly through some miraculous means." But sounds like you're allowing me to wave my magic wand here. Somebody comes to us and say, a mayor or whatever, says, we have this location where we want you. We're going to make it easier for you. We'll sterilize the airspace, whatever it takes, and we will partner with you to create local demand and a business. That would be super exciting. So I guess you're probably coming at it from a supply side perspective, and my answer is that I'd actually would like companies to start it up more on the demand side.
What's the most common misconception or misunderstanding about advanced air mobility, Chris?
I don't know. I mean, I don't know what people think. I mean, there's skepticism, obviously. There's actually a really good book that I've read recently called "Where's My Flying Car?" Which talks about all the reasons we don't have flying cars today. But by and large, because flying cars have been talked about for so long and have disappointed for so long, I think there's a sense that this is yet another fantasy. And I don't think people understand just how much the technology, the enabling technologies have changed from the 1970s, 80s, 90s, all the previous times. The combination of autonomy and electric power plants is a complete game changer, and I don't think people completely realize that this flying car actually makes sense.
We often ask about outcomes, what outcomes will be improved as a result of this technology, but I think you've addressed that throughout the talk. So as you prepared for the podcast, Chris, as you thought about what's the one point you'd want to give to our guests, what one point would you want to leave with them?
I guess the point is that everyone everyone agrees that autonomy is the future, but not the present, because of all the things we talked about. And I would encourage them to test that thesis. The more companies, and I mentioned the coalition we have of companies. So one of our Whisk, which spun out of Kittyhawk, is doing Autonomy. We have companies that are like Reliable Robotics and Merlin X-Wing that are converting existing aircraft to autonomy. We have big drone companies like General Atomics, and we have small drone companies. I think that there is enough going on out there in autonomy between small drones and these other things I've mentioned that something's going to happen. Something's going to change the nature of how we think about autonomy. It's going to happen. I think you had Brenton Groves talking about change at the policy level. That could be Congress. It could be the White House. But, we talk about national industrial policy or national security priorities. China's going all in on electric transportation and autonomy between the cars and the EHongs, et cetera. This is a wake-up call for us in the United States. And right now there's a small band of us, radicals who are doing it now rather than later. I think the skeptics out there are probably going to be proved wrong. Not that it isn't going to be a long path for certification, but that we're going to achieve levels of performance that are certifiable, or at least should be considered certifiable sooner than people realize. And we're just really good at this stuff, and we're starting to demonstrate with enough hours of flight time between the drones and the other things we're talking about. We're starting to get statistically significant evidence that autonomy is ready for prime time.
Luca, that's terrific, Chris. Luca, any other questions from you, sir?
No, thank you so much. This was really, really fascinating.
Thank you for having me, and thank you for this podcast. This is this is my go-to. I have to admit I listen to 2X, and thank you for speaking clearly, because that helps.
That's good feedback. Thank you.
But it's you power me through my runs.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.